This is Axon, the Air University Teaching and Learning Center podcast. At Axon, we make connections between teachers, learners, and ideas in military education. The opinions, conclusions, and recommendations expressed or implied in this podcast are solely those of the speakers and do not necessarily represent the views of Air University, the United States Air Force, the Department of Defense, or any other U.S. government agency. Follow us online at www.airuniversity.af.edu/TLC or on Twitter at AirTeaching for more.
Good morning. Welcome to the Air University Teaching and Learning Center podcast. It's my pleasure this morning to speak with Colonel Don Stryker Haley and Dr. Steve Ellis. Colonel Don Stryker Haley is a career F-15E pilot and military strategist. In his current role as Commander, AETC Detachment 62, he supports AFWERX Agility Prime by accelerating the commercial and military adoption of electric vertical takeoff and landing vehicles, eVTOL, that's a mouthful, through curriculum development and operational training. Welcome, Stryker. And we also have Dr. Steve Ellis, a 25-year Air Force veteran with over 40 years of experience as an instructor, curriculum developer, training program evaluator, and learning systems innovator. He is a scholar practitioner serving as the learning coordinator for the AFWERX Agility Prime program, helping bring electric aviation to the forefront. And I am Dr. Megan Hennessy, the director of the Teaching and Learning Center. Welcome to you both. Thank you for joining me this morning.
It's good to be here, Dr. Hennessy. Thank you for having us.
Thanks, Stryker.
Yes, thanks for inviting us for this. This is a great opportunity for our small detachment.
Thank you. Yes, I'm so excited to dive into what Detachment 62 does and how it's connected to teaching and learning. So please describe your current project and why it's important from a national security perspective.
You bet. I'll start off there, Megan. So I think it may be helpful to start out kind of the broader perspective. Our team works directly with AFWERX. AFWERX is the innovation arm of the Air Force, and the AFWERX mission is to connect innovative technology developers with airmen and guardian talent. And then we work with a program called Agility Prime. And Agility Prime is a program under AFWERX that's focused on this eVTOL industry, so electric vertical takeoff and landing. A lot of people call eVTOL, it's been referred to colloquially as the third revolution in aerospace. If you think of the Wright brothers to the jet age to the electrification of aviation, it's a really exciting time in aerospace, and specifically working with these vehicles that are being developed, electric vertical takeoff. And then you said it's a mouthful.
Yes.
There's actually an Anderson Cooper, a 60-minute special. And he actually talked about how it's kind of an awkward term, but an awkward term to describe a really exciting technology. As we look at what eVTOL can be, a lot of people have projected that this is going to be a multi-trillion-dollar industry. And more specifically, I think the big aha is electrification is deemed to be something as the democratization of air travel. So hopefully making it a lot more affordable to do shorter, regional kind of operations. It's going to change cargo operations. It's going to make your Amazon packages show up even more on time for Christmas. So it's going to be it's a really exciting technology. And so the project that we're doing is specifically looking at around learning. And because eVTOLs are being designed with distributed electric propulsion, and they're being designed with all new technologies, composites, you're kind of building a little bit off of what happened in the drone industry, small UASs. A lot of these vehicles are going to be a lot more simple from an operator perspective to operate than traditional aircraft like your Cessnas and things like that. And the other thing that's different is that they're not airplanes and they're not helicopters. They're kind of a combination of the two. So when you take these trends of technology making vehicles more simple to operate and more accessible to the average public, when you take the fact that it's not a helicopter, but it's not an airplane either, so you kind of get some very interesting things from a learning perspective. So our project has been focused on trying to understand how learnable these aircraft are. We're looking at some of the leading manufacturers. We want to try to understand, compared to what our history has been in learning how to fly helicopters and airplanes, what do we imagine the future looking like with this new future? So the experiment has all been around trying to understand what that looks like, and that obviously is going to form what kind of policy we have, what kind of rulemaking the FAA does and other international bodies, and also how we train future operators of these aircraft.
Thank you so much. Yes, I can speak from experience. When I was visiting Steve on site there in San Antonio a few months back, I got to try one of the simulators, and it is incredibly difficult. So I'm glad to hear that you're putting significant time and thought into the best way for people to learn how to do this. Steve, I'm wondering if you could go into a little bit more on the research design. Stryker mentioned that you're doing a study around the learnability behind eVTOL. Tell us more about that.
Okay. We didn't actually start out with a research plan in mind when we stood up the DET. It was really to train the first generation of eVTOL pilots. And what we quickly realized is there were a lot of claims and assumptions that these would be easier to learn than traditional aircraft, but we didn't have any data to back that up. And some of the estimates were wildly varying. So we decided that since nobody else has studied it, we would research this in an operational environment. And so it's ops research. It's conducted in a hangar, not in a lab, with our best available resources and the people that we have available. So what we built was a quasi-experimental 2x2 matrix study where we're looking at pilots and non-pilots in two different vehicles, one highly automated and one less automated vehicle, because the vehicles have various levels of autonomy in this fly-by-wire design. And our goal is to capture as much data as possible. So we're using a research model that collects data from instructor pilots, the simulators. We have some psychometric tests. We have some knowledge tests and surveys. And overall, with 80 subjects, we have somewhere north of 12 million data points.
That is insane and amazing. As a researcher, I'm jealous.
Well, thanks.
Yeah, I've had a hard. I hang out with all these PhDs that get really excited about data points, and I have a hard time completely comprehending the excitement. But it's been explained to me by our statisticians, and now I have an appreciation for it at least. But yeah, it's a rich data set.
Yes, Steve, did you want to say anything more about the research design?
It's turned out to be a very robust research design. Like I said, 12 million data points is gathered us or afforded us a lot of opportunity to look at some of the nuances in the data that we've collected. So we've got objective data, we've got subjective data, we've got quantitative data and qualitative data. So now we're living in a data-rich environment.
Yes, I think that's putting it lightly. So what do you do with the data, and who's looking at it? Who's helping you make sense of it? How do you make sense of it? Tell us a little bit about the analysis phase.
The analysis phase has been quite interesting. We did partner with a research company that helped us with a lot of the data analysis, and they're helping us pour through all this data. And they had some very useful data collection tools that helped us to standardize this research. And we're also partnering with Embry-Riddle right now. We just got a partnership started with them. We're also going to be working with, I think, Florida Institute of Technology to let some of their researchers and grad students have access to this data. The data analysis is ongoing. We've done some to begin with. And when you have that much data, you just it's kind of like eating an elephant, just one bite at a time.
Yeah, I think we started with, with all the data, when you're like, how do you direct the analysis? As the commander, I've tried to take the handle there as best I can with a lot of help, of course. But I've started with what I would consider to be operationally relevant questions that I think we can answer, questions that are going to matter for our audience. I think are the manufacturers. What feedback can we give to them as they're designing these aircraft? Also policymakers. So we're interested in influencing policy and helping folks in the FAA and larger international bodies understand how we're going to regulate the industry. So we've asked questions, for instance, like we asked, how do automation features in eVTOL, and specifically when you look at distributed electric propulsion, how does that impact learning curves and operator proficiency? And then we just looked at specifically, because it's not a helicopter, because it's not an airplane, we wanted to understand how do aviation experience impact your learning curve. So if you're a rotorcraft pilot, how quickly do you adapt to this new type of aircraft? If you're a fixed wing pilot, how well do you adapt, especially when you get into the takeoff and landing phases, which are more vertical oriented. We teamed with the test pilot school as well, and we looked at things from a human factors point of view. So we looked at psychomotor resource availability, and then how does that affect performance? What parts of your psychomotor capabilities are being taxed the most, and what does that mean for design? So we can kind of give some human factor feedback. And so with this data set, we go with those questions, and then we run the analysis to try to answer those specific questions. And we have a list of probably about 15 or 20 different questions. We've worked through about half of them at this point, where we've come up with some reasonably good answers from the analysis that we have. And then we try to find environments where we can then brief them. For instance, we were just at ITSEC, and we took a subset of those questions, answered those, submitted a paper, and then we were able to present on it. So we're slowly going through the analysis and finding places that we can share what we're learning with the larger crowd of interest in eVTOLs.
Yes, and count the TLC in in that interest. Can you share any initial findings?
You bet. A couple of things. I'm actually pulling up some stuff as we hear. So we first started with this of some of the questions that I was asking. So we wanted to try to understand automation features. A couple of the different aircraft that we looked at, they're representative of different, I would call it, maturity levels in production, because different companies are going after different markets and they've been around for a different amount of time. So you have differing levels of maturity in prototypes that we're working with in the Agility Prime program. We are able to kind of compare apples and oranges and learn from them. So for instance, one of the manufacturers we're working with, they're at the stage of development where they haven't input a lot of automation features into their control laws yet. So it's pretty much like it's still fly by wire, but it's pretty much the operator is directly more or less controlling the aircraft. There's very little automated hover features or automated altitude hold or anything like that. So what we're able to do is look at that aircraft, which I think would be representative of distributed electric propulsion. When you have multiple motors, you can't individually control 6 engines like you would maybe in a multi-engine a 2-engine Cessna type aircraft. So there's going to have to be control laws around that, just like when you have a drone. I can't control every little electric motor. So that I would say that's the most simple, the basic starting level. And then we have a manufacturer who's been around a little bit longer than some of the others and has a lot more automation features, so we can compare. And what I think we learned is just distributed electric propulsion, just the fact that you're going to have some level of augmentation and just kind of your entry level, very little automation. We find that it is a very learnable aircraft that folks that don't fly helicopters can, in our experiment, just in a couple of hours, they're able to gain high levels of proficiency in very difficult tasks like takeoff and landing. So that's really interesting. And of course, as you might expect, as you add automation features in that, as you automate your altitude and airspeed control, as you automate your hover functions, that the learning curves are the same, but your baseline is a lot better. And what that means is you get more consistent performance. Even people who don't have, and we tested their psychomotor capabilities of people that maybe don't have as good as quote unquote hands. Like there are some folks that maybe have better pilot hands, if you will. The automation features help folks that maybe don't have the same eye-hand coordination. And so you get a better consistent level of performance. What that means ultimately for the industry is it's going to be safer to operate. You won't have to train as much, or the currency requirements will be such that even people that don't fly it very often, they will be able to consistently perform. And so we're able to show, what feature sets, when you put these automation features together, it increases safety, increases and improves overall performance. And so we're able to measure that and have real data to show all that, which is really exciting.
That is really incredible. Congratulations for everything
Thank you.
You and your team have done thus far. In AETC, Air Education and Training Command, and here at Air University, we are always talking about force production. How does your project relate to that
So one of the things that we did in our study is we included people with no piloting experience. And this is a long way to get to forced production. Our initial assumption was anybody who goes into one of these vehicles is going to be a highly qualified pilot. And we debated this amongst ourselves. It's like, do we put people with no piloting experience in there? And so we decided, we're going to do that for the study. And we put people with no piloting experience in there and found out that, yes, they can learn how to fly these things, and they learned how to fly it in a relatively short amount of time. They're not as proficient as the experienced pilots, but they have a similar learning curve. And when we look at the data from the industry, they're looking at some estimates, 10,000 pilots a year needed in these aircraft, in addition to the pilots that we already are short in the U.S. And so this is going to be a large global market that's not going to be able to that's going to require a lot of new pilots. And so now that we're starting to see that it is possible to put somebody who's not flown a Cessna, who's not gone through a flight school, and put them directly into an eVTOL, it opens up the aperture for what a training program for a manufacturing company would look like, or for a training company in the civilian market. How do you train a large number of pilots? And then what does that training look like? How quickly do they pick up these skills? So we were able to do some projections based on our data of how long it takes for ab initio students, the students with zero piloting experience, to safely and effectively perform simple aircraft maneuvers. And we were able to project how long that training for takeoff or en route flight would handle. And then this isn't the airmanship piece of it and communicating with the air traffic control, but just the stick and rudder skills, so to speak. And so we're able to give a projection of what that looks like. And that was some of the data that we provided to the G35 committee, or SAE. This was that international committee on advising rulemaking bodies around the world.
I think just to add on to that, Megan, I think some of the more exciting work that we've been able to do is really to inform competency-based training. So I think there's been a lot of talk around competencies, and I know from an international perspective and from kind of the civilian perspective, there's a desire to move towards that. Certainly the military, we're interested in that. I would say that our understanding and how you take and apply competencies is still developing. That still requires better levels of understanding, trying to move away from task-based training only. So I think a lot of our work is really helpful in informing and helping us to understand competencies. For wanting to accelerate training, there's some things you can't, you got to get air, I call it air under your butt, you have to have aviation experience. There's just some part of that you can't get away from. To teach airmanship, you have to be in the air. But there's some pieces that we can accelerate, I think we're learning where certain training devices or certain approaches we're able to accelerate our development of certain competencies more quickly. And then there's some things you just need those aviation experiences. And I think that when you kind of start with a completely new industry and you're able to more or less clean sheet training design and start with competencies instead of taking a very task-based system and then trying to convert it to competencies, it helps us to be a part of that conversation. And a lot of the research that we're doing is helping us to advance our understanding and the progress with how we move forward with competency-based training.
Thanks, Stryker. You are speaking my language now in terms of competency-based education, outcomes-based military education. And I know that both of you have a significant training and development background. Can you share a little bit perhaps about how that has influenced your work on this project?
Steve, you're the guru. I'm gonna let you go first.
So I've been interested in student-centered learning and competency-based training for several years now, and have gotten an opportunity to work with some of that and do some research and publish some. So I think, like Stryker said, being able to walk into a brand new project with a clean sheet and no expectations of what training is supposed to look like, and start with a clean sheet approach has been huge. And be able to apply some of the things that were, for me, largely theoretical in the past, and say, all right, now we're applying these things, and how does this look in application, and does it really work? Do the theories really hold true? I think that's been a huge huge benefit for me on being able to apply some of the the experiences that we've seen and some of the things that we picked up over the years and say, all right, this is what training should look like, or we want to test that model and see if our assumptions hold true. And so we did actually build our training from a competency-based approach using a situated learning environment. And for me, that was quite unique to be able to see that actually put into action and realize that, yeah, this really does work better than we had anticipated, that we didn't run the ship aground, so to speak. Stryker?
Yeah, so my background is in not necessarily looking at things from a competency. There's just being a T-38 instructor pilot to start out my career, and then an F-15E instructor evaluator. So flying training just from a military perspective. So talking about competencies has been new for me. We've now spent 2 years being a part of the competency movement, if you will. I feel like it is a bit of a movement and being involved in a lot of the discussions. So I think I bring a little bit more of the operational flavor of, okay, how does this actually work? Where I think Steve brings a lot of the expertise and the academic piece behind it. And we have that experience not only in our team, but through the network that we've created and partnerships. What's mighty about our team is not necessarily the amount of people that are on the core team, but the partnerships that we've built over the last 2 years with academia, with industry. And so we're a part of, like Steve mentioned, the SAE G35. We worked with a number of universities, and we're involved in other research. And then we kind of I bring the so what out of it. So what does this actually look like for military pilot training? I think that has helped us with our research project and specifically is not to be just completely academic, but to be operationally focused. So how do we take our research and how do we inform things that really matter for day-to-day activities in the Air Force and beyond? That's, I think, what's made our research a little bit more. It's not just research in a vacuum. It's not just a dissertation but it's connected to a lot of realities, not just with our team, but with the partnerships that we have.
It seems like you both have very complementary skill sets along with the rest of your team. But I would not be doing my due diligence as a podcast host if I didn't ask you, what are some of the critiques that you've run up against and how do you counter those? Are there people who disagree with the way that you've approached this project?
That's a really good question. Steve, you want to go first, or do you want me to go first here?
Well, I'll take it from the academic side. The critiques, anytime you do research, there's nothing that researchers love more than to poke holes in other people's research. And when we built the research proposal, the research plan, the idea was to plug as many leaks as possible. How do we make this as defensible as possible? Because when you present your research to a bunch of other researchers, they're going to look for things like, well, that's the wrong statistical test, or your statistical test. Did you do a power analysis? How did you come to that conclusion based on these statistics? Or how do you know that was the right statistic to use? So a lot of thought goes into that to make sure that our research is defensible, and the other is to scope it properly, that we're not trying to solve all the world's problems, but we can present within these guardrails that or we can say authoritatively within these guardrails that this bit of data is as accurate as we could make it, and the research findings are as solid and concise as available in an operational research environment. We're not in a laboratory. When you're doing human factors and human social science research in an operational environment, it can get messy. Try to put in as many controls as possible to eliminate that from an academic standpoint. Stryker, over to you.
Yeah, I would say that most of our resistance that we had to this particular project was, from my perspective, I'll talk from the operational perspective, it was probably in the very beginning when we came up with the research proposal. We were talking with some of our OEM partners. Of course, in this industry, Agility Prime, we work with a number of OEMs. They're all competitors in some way or another. And so there's always concern about intellectual property and then also managing public perceptions. And if you find one thing, and if you have the wrong context, if we have a finding, but it's absent of the context that, hey, this is a prototype vehicle, that it's like, they're now 4 prototype evolutions down the road and they fixed all these problems. And so they, worry about investors and things like that. So there's a lot about controlling messaging and making sure that we're being a good partner with our OEMs. And so we had to work a lot with the relationships at the beginning when we were pitching some of our research ideas. And then initially there was this, I don't think people quite understood the value or the potential value at first. So there was some resistance of investing the money that it's taken to get the contractors and the sims and everything. But what we found now in retrospect is that the data that we produce has been very helpful, and it continues to be helpful. And it's whatever, we've shown up at a number of venues, be it a large training conference like ITSEC, or in a regulatory meetings with SAE or the FAA, where we're the only folks in the room who have hands-on experience and actual data to support some of our opinions and thoughts about how rulemaking should go, or how we should approach or have certain curriculum approaches. And so we've found that the data that we've produced has become very helpful. In the beginning, though, there was a lot of resistance, and it was mainly from the OEMs. But I think what we've been really careful to try to understand what the OEMs' concerns are, and to be a good partner in the way that we message things, the way we share the data, and with whom we share the data. And so I think part of it is just relationship management. And I think that we've done a good job of that. So that was most of it was around relationships and how you handle IP. I think we've navigated that really well, though, the last year.
This sounds like such a complex project. As we're winding down, is there anything else you want to share about the future of this research initiative and what's next for eVTOL?
You bet. I'll jump in on that one. So Det 62, we don't consider ourselves a research organization. We saw a opportunity and a kind of a hole that needed to be plugged. So I think our ears are open, and we're looking for how we can help further the conversation. And so I think there's a lot of work that we can do to try to advance our understanding of competencies as we apply this kind of clean sheet design to this industry and help inform others. So I would say over the next year or so, we're going to be taking some of the work that we've already done as an Air Force and then trying to apply that to the industry writ large. That's some of the things that we're starting to draw out, and that certainly in the new year, we're going to put some meat on the bones of our thoughts over what's next for us. So I think that we're going to continue to help fund and direct some of the research activities. We're going to focus a little bit more on competencies over the next year. And a lot of that has to do with the overall maturity of the OEMs as we get closer to transitioning these technologies. We're actually buying our first eVTOL aircraft next year and bedding them down at Edwards and Eglin. And as we start putting actual airmen and guardians in these aircraft, we're going to take our research from kind of more of the basic research and understanding some basic questions into a little bit more operationally flavored, competency-based curriculum development kind of activities. And that's what you'll see out of us over the next year.
Wonderful. Thank you so much, Dr. Ellis, Colonel Haley. Thank you for joining us today. How can we stand by for more information? How can we reach out to you to learn more?
The DET's going to be around for a while, and we will continue to look at this, like Stryker said, from a clean sheet approach. You can reach out to us through the AFWERX community and through the new AFWERX director, Colonel Lee. We will like Stryker said, keep our ear to the ground and see what's coming up that we can put some of our muscle behind and help advance. Like I said, we're thinking that a couple things are on the horizon. The competency-based training, of course, is going to be a big thing. Another gap in the research, kind of so to speak. The other may be helping with emergency procedures and eVTOLs, because nobody knows what those look like yet. And so how do we continue to further that industry? But if people need to get in touch with us, easiest thing to do would be go through the AFWERX directors or reach out directly to us.
For AU, this certainly, with our partnerships that we already have with academia, like I definitely have an AU be involved with those activities. I'm looking forward to growing that partnership. A lot of this has been, I think a lot of our success that we've had over the last couple of years has been not necessarily the work that we're doing, but the way that we're able to connect different organizations, just because of the relationships that we have, that we're able to have through the Agility Prime program with the OEM partners, and that the CRADAs and the relationships that we have with industry and with academia allow us to kind of be the kind of the team that brings everyone together, especially around the questions around learning and curriculum development for eVTOL. So I think we're kind of right in the middle of that space, and we're a good connector and a good partner with this industry and the way it's growing.
And I'm going to try my best to get you to present at the Military Scholarship of Teaching and Learning Forum, the NSOTL Forum, in December of 2023. So our listeners hopefully can look forward to learning more from you then. Thank you both so much, Steve and Stryker, and we look forward to hearing the other good things that come out of this program. Thanks for joining today.
You bet. Thank you so much, Mike.
Thank you for listening to Axon, the Air University Teaching and Learning Center podcast. Stay current on these and other ideas in military education by following us online at www.airuniversity.af.edu/TLC or on Twitter @AirTeaching.